All right, so first up here, they say that all of these are algebraic errors, so they want us to prove that it's wrong. And so we should come up with some numbers here that make this wrong. So for this one here, you can make these numbers kind of nice and simple. So I would try out like 2 plus 3. So 2 plus 3 squared is obviously 5 squared, and that's 25. And then if I did it on the other side, it would be 2 squared plus 3 squared, so that's 4 plus 9. Which is obviously not 25, but rather 13. So by using 2 and 3 for A and B, I kind of proved it wrong. And so my answer here is going to be 2, 3. You can see that they just kind of wanted me to match that format of the numbers I chose. There's multiple correct answers to all of these, but there are some answers that are incorrect. So you do need to kind of test them out and make sure that they actually don't work is what we're going for, because all of these are common misconceptions. All right, next up here. This is kind of a similar idea to the last one, except that some of these are true. So if it's true, we're going to go ahead and enter true. And if it's not true, we're going to come up with numbers that prove it to be not true. So for part A here, you actually can divide both of these things by 6. So then 6 over 6 would be 1. And then A over 6 would obviously be A over 6. So this one is actually true. So then the next one here, we're not allowed to cancel out those ones because of the addition. So this one I know is false, and to prove it wrong, we can go ahead and just use, I would just go ahead and use 2 and 3 again. And I'm going to check it to make sure it doesn't work here, because I'm pretty sure that this is false. So we have 2 plus 1 over 3 plus 1 equals 2 over 3. So now it's saying that 3 over 4 equals 2 over 3, and that is incorrect. If you wanted to look at this as a decimal, it would be like 0.75 equals 0.67, which is obviously incorrect. So once again, just like last time, I would list my answer, like it says, a coordinate point here, 2, 3. And I'm just matching the format they've had over there. All right, next up here, they want the domain of this expression. So the rules for domain is a denominator, and this is for domain. A denominator cannot equal 0, and the inside of a radical must be greater than or equal to 0. I don't have either one of those things here, so whenever that happens, it's just all real numbers. All right, next up here, I'm going to follow my domain rules, which once again, we have a denominator cannot equal 0, and then we have the inside of a radical must be greater than or equal to 0. And so in this case, I have a denominator, so I'm going to set that not equal to 0 and solve. So I'm going to factor that, x minus 8 times x plus 3, not equal to 0. So x cannot equal 8, x cannot equal negative 3. All right, on this one, I'm going to use my other rule, which is that the inside of a radical must be greater than or equal to 0. So if I isolate x here, it would be x is greater than or equal to negative 9. All right, these next two here, we're going to simplify, which really just means to kind of factor and cancel. So I'll do number 7 here. So I can factor the numerator as 2 minus x, 2 plus x, difference of perfect squares. The denominator is a perfect cubes. So I'm going to do one small and one big parentheses. So I got the x and the 2. X times x is x squared. X times 2 is 2x, and 2 times 2 is 4. And we'll go same, opposite, always positive. So then, let's see, I can't cancel these out right now, but I can go ahead and on this top one, I'm going to take a negative 1 out front and change that to negative 2 plus x. So now it actually will cancel out with the x minus 2 on bottom. I would go ahead, and so I have negative 1 times 2 plus x over x squared plus 2x plus 4. I would always go ahead and distribute in the numerator, so I'm going to call that negative 2 minus x over x squared plus 2x plus 4. All right, next up here we have is division. So for division, we always multiply by the reciprocal of the denominator. So this is going to be 4x squared plus x minus 3 over x squared plus 7x plus 10. And now when we do that, this turns into multiplication instead of division. So now I'm going to factor kind of everything here. So let's see, what do we got here? Well, the x plus 5 obviously does not factor. The 6, that's a difference of perfect squares down there. 4x minus 3, 4x plus 3. And then over here, we got a diamond, so that's 10 and 7 would be 5 and 2. So x plus 5, x plus 2. And then probably our hardest factoring is up here. So it is also a diamond. So that's a times c is negative 12, and then b is 1. So it'll be 4 and negative 3. But I have to do the grouping technique, so I'll do this over here. 4x squared plus 4x minus 3x minus 3. And that's kind of splitting up this middle term here. So now I'll do the grouping, and we do 4x times x plus 1 minus 3 times x plus 1. And that leaves me with 4x minus 3 times x plus 1. So I'll put that up here. Go ahead and cancel stuff out. So I can cancel these out. Boom, boom. And x plus 5, boom, boom. And that looks like it. So my final answer then, which I'll go ahead and write down here, would be x plus 1 on top over, and I'll leave this in factored form as 4x plus 3 times x minus 2. Or x plus 2, excuse me. All right, 9 and 10 are also division. They kind of just showed it a different way, but on both of these, we can go ahead and multiply by the reciprocal. So that's going to be multiplied by x squared plus 12x plus 36 over x. And so now I can go ahead and factor this, multiplying to 36 and adding to 12, which would be 6 and 6. So this is really saying x to the third over x plus 6 times x plus 6, x plus 6 over x. So I can cancel out here, and then I can actually, if you think of this as 3x times x times x, I can drop this down to the second power while canceling this out down here. So that leaves me with x squared times x plus 6, which you could probably write it like that, or you could write it as x to the third plus 6x squared. All right, number 10 is very similar to number 9, so I'll let you guys do that. Now we'll move on to addition and subtraction, which we really got to think about common denominator here. So I'm going to multiply this one by x plus 6, top and bottom. And so that's going to give me x plus 6 on bottom for our common denominator. On top I have 9x minus 1. And then on this one I need to make sure I distribute this as a negative 2. So I get negative 2x minus 12. We'll just combine the like terms up top. So I get 7x minus 12. Oh no, mine's 13 over x plus 6. All right, next up here we'll do 12 and 13. So for these one, I'll go ahead and do 13 here. So we got to find a common denominator here, but if you factor this denominator, negative 28 and negative 3, you'll see that it's negative 7 and positive 4. And you'll see that it does have that in common with the other two parentheses there, which all kind of happens a lot. So I'm going to multiply this one by x minus 7, and I'm going to multiply this one by x plus 4. And so we're going to put this all together with our common denominator of x minus 7 times x plus 4. In the numerator I have x, and then here I have to distribute a negative 3 into the x minus 7, so that's minus 3x plus 21. And here I have to distribute a negative 7, which is negative 7x minus 28. All right, so now I'm going to combine like terms in the numerator. So let's see, that would be negative 9x. And then, let's see, that would be negative 7. If you combine the 21 and the negative 28 over that common denominator of x minus 7 times x plus 4. All right, next up here we got the compound fraction. So for these ones, I like to simplify the numerator and denominator. So I'm going to think of this as 1 over 1. So I'd have to multiply that by y over y to get the common denominator. So that's going to be y minus 2 over the common denominator of y. And then you're going to do the same thing on bottom, and then multiply by the reciprocal and see what you can cancel. All right, same idea here. I'm going to go ahead and get the common denominator up top. Now on this one, the common denominator, I'm going to have to multiply by 2 plus x plus h over here. And I'm going to have to multiply by 2 plus x over here. So the only thing you got to be careful on this one is you're going to distribute this as a negative 1 over here. So that's going to be 2 plus x on my left side. So I'll distribute the 1 over there. And then over here I have negative 2 minus x minus h. And it's going to be all over that common denominator of 2 plus x times 2 plus x plus h. And that's going to be all over h. Okay, So now we'll combine like terms up top, which means really cancel stuff out. So we're left with negative h, and I'll go ahead and multiply by 1 over h now. And you can see that these h's cancel out. So I'm left with negative 1 over 2 plus x times 2 plus x plus h. All right, next up here, we're going to simplify this. I don't think the u substitution would help me here because I could use u's for these, but this one does not. So instead of that, I'm just going to expand the numerator. Now, this first one's going to be the toughest expansion because on that one, we have to write it 3 times and then FOIL and then do like a super FOIL. So I'm going to do that over here. So I'll FOIL these together, and that gives me x squared plus, and then we got xh, and xh is 2xh, and then plus h squared. And then we're going to multiply that by x plus h, which is going to be a box for the way I do it. So I'll put x plus h over here, and we get x to the third, 2x squared h, xh squared, x squared h, 2xh squared, and then h to the third. So I'm going to have my, I'll write those out, but I'll combine like terms, which is like all the diagonal ones here. So I got x to the third plus 3x squared h plus 3x h squared plus h to the third. And then we'll go ahead and continue with this. We'll distribute that negative 8, so that becomes negative 8x minus 8h. And then we'll distribute this, we got negative x to the third plus 8x. Yeah, plus 8x. Okay, cool. So now we'll cancel. I can cancel out that with that, and the x third with the negative x to the third. And this is all over h. And what I notice here is that all of these terms that are left all have an h in them. So what I'm going to do is I'm going to pull an h out front, which will leave me with 3x squared from this piece, and then 3xh from that piece, h squared from that piece, and negative 8 from that piece. I want to pull that out front so I can cancel it down, and then that's my final answer in there. All right, these ones right here with the negative exponents, I can't drop those down to the bottom because of the addition. So what I need to do is kind of make them their own little mini fraction here. And so I'm going to call this 5 over x plus 5 over y. And you'll notice that I did not drop the 5s down because those do not have the negative exponent. And so then this one's going to be 9 over x plus y to the first. So I just kind of dropped them down to their own little mini fraction. Can't drop them to the bottom of the big fraction because of the addition. So now I'm going to do some common denominator here. So we're going to multiply this by x and that by y. It's going to be 5x plus 5y over xy. And then I can go ahead and multiply by the reciprocal here. So times x plus y over 9. Okay, so I don't see anything that can actually cancel here, but what I can do is I can GCF a 5 up here, call this x plus y. So then I could write that a little bit more simply by calling it 5 times x plus y squared, since those two are multiplying by each other, over 9xy on bottom. All right, here we're going to do, we got simplified the expression. We're going to do a u sub. So I'm going to let u equal x plus 4, and we'll need another one, y equals x minus 8. So I'll write this as 3u squared, y squared minus 2 u to the third y over, and that's going to be all over y to the fourth. So up top here I see I can factor out a u squared and a y, which will leave me with 3y minus 2u all over y to the fourth. You can see I can cancel out one of these y's now that that's factored out front. And so now I can plug everything back in. So I have x plus 4 squared. And then in here I have 3, and I'm going to do a bracket for x minus 8. And then minus 2 with another bracket for the x plus 4. And then that is going to be all over x minus 8 to the third. Okay, so now we're going to go ahead and distribute up here. So we get 3x minus 24, and I'll distribute that as well. So we get a negative 2x minus 8. So we'll just combine like terms in the parentheses now, and we will get, let's see, x, 3x and 2x can subtract, and then minus 32. All right, and then I'll have this one as x plus 4 squared, and then the bottom as x minus 8 to the third. I think that's fine to just leave it like that. All right, next two here are pretty similar. I'll go ahead and do number 20. So for this one, we're going to let u equal 8 minus x squared. I think I only need one here, one substitution. So I'll call this u to the 1/2 plus x squared times u to the negative 1/2 all over u. And so it looks like I can GCF up top u to the negative 1/2, which would increase this to a full u and just turn that into x squared. Now what I would do now, since that negative exponent's factored out front, I can move it to the bottom and call it u to the positive 1/2. Since this one is u to the first power, I'm going to call that the 2 over 2. And I can actually add those exponents together and call that u to the 3 over 2 power. And then I'm going to plug u back in. So I get, on the bottom, 8 minus x squared to the 3 over 2 power. And on top, I have 8 minus x squared plus x squared, which can just simplify to 8 over 8 minus x squared to the 3 over 2. All right, next up, number 23 here. These are going to be perfect cubes. And you can kind of visualize this as a cubed. And obviously this one's just b cubed. So we're going to do our small parentheses and big parentheses. So your first one is going to be a cubed and then just b. And then for my next parenthesis, I do the first one times itself. So a cubed times a cubed is a to the 6th. And then I multiply these two together. And so that's a cubed times b. And then I do the last one times itself, which is b squared. And then we just do SOAP for the pluses and minuses. I'll let you guys do that. Okay, next up here, number 24. So for this one, we're going to do a GCF first. We're going to take out the smallest power of x, which is actually negative 1/2. And that we'll just leave that with 6. And then this one will increase to 5x. Because remember, if we take out a negative exponent, it's actually going to add that much. So it's plus 5x to the first. And then 3 over 2 plus 1/2 is 4 over 2, which is just squared. So then I would just rearrange this inside and call it x squared plus 5x plus 6, and then I would factor that. So that would be x plus 2, x plus 3. And then for the x to the 1/2, I would just go ahead and throw that on the bottom and write my answer like that. Number 25, I am going to take out x to the positive 1/2. So this time my exponents will decrease because I'm taking out a positive exponent. So this one will decrease by 1/2 and go to the 4 over 2 power, which is just squared, and minus 81. And then I would just break down x squared minus 81 some more. I'll let you guys do that. All right, next up here, we're going to do some u sub. So we'll let u equal a squared plus 2a, and we'll call this u squared minus 2u minus 3. No GCF there, but I can factor it into u minus 3u plus 1. And so I can plug that back in, a squared plus 2a minus 3, a squared plus 2a plus 1. And then we'll factor that some more. So I'll let you guys take it from there. So always got to plug back in and then check if we can refactor. All right, next up here, we have to kind of deal with some different kinds of exponents. So negative exponents will flip the fractions. This will be 25 to the 1/2 over 16 to the 1/2. If we make those positive, it flips it, and which will be the square root of 25 over the square root of 16. And so you got to simplify that, so that'd be 5 over 4. Okay, next one here, we do the square root of, and not the square root, excuse me, the cube root of negative 8, and then we'll do that squared. Now the cube root of negative 8 actually is possible because you can think about negative 2 times itself 3 times would give you negative 8. So negative 2 squared, of course, is 4. Part C looks the same, but when you don't have parentheses around the negative, it's kind of, you could think of it as being outside. It's really the same process as before. So it's the cube root of 8 squared with a negative out front. And so I'll let you guys do that one. All right, next up here, A and B. I would always take care of the parentheses first. I'll go ahead and do B here. So I send all that exponent into all of these. So this will be 4 to the 3 over 2, s to the 3 over 2, t to the 3 over 2. And then this one as well. So this would be 8 to the 2/3. Now this one is going to multiply by the 6 that's already there. So 2 over 3 times 6 over 1. And that'll be s to the 4th. And then negative 4 over 1 times 2 over 3 is negative 8 over 3. So that'll be t to the negative 8 over 3. And then I have, oh, it's negative, okay. So now over here, I got to do the same thing, send in that negative 1. So it'll be 2 to the negative 1, s to the 4th, and then 3 to the negative 1, s to the negative 1/3. Okay, next thing I like to do, I'm going to take care of kind of all these numbers here. So this one will be the square root of 4 to the 3rd. And so the square root of 4 is 2, and 2 to the 3rd is 8. So I'll put that here. 8 to the 2/3 is kind of the other direction with it. So the cube root of 8 squared, and so that's actually 4. And then I'm going to move all my negative exponents here. So these are all going to stay put. But then I'll move the t to the 8 over 3 up here. And then over here I'm going to move the 3 up there, the 2 down there, s to the 4th, s to the 1/3. Oh, but you know what? This was actually supposed to be a t to the negative 1/3. So if you kind of look back here, so I'm going to make that t to the 1/3. All right, move that to the top. Okay, so now I see that I can partially cancel this 8, which leaves me with 2 up top, but that can then cancel out with the 2, so that's good. The s to the 4th, I can actually cancel out the 4th powers right away, so that's nice as well. And so now I'm left with, what do I have left up top? Well, I have a 3. I have s to the 3 over 2, which is not going to add anything. And then I have all these t's that I'm going to have to add together. So, I actually notice here a little shortcut. So I have the 1/3 power here and the 8/3 power there. So those already have common denominator, so I can add those together. And that's going to be 9/3, which is just 3. But now I need to add that to the 3 over 2 power. So 3 over 1 plus 3 over 2. And so get a common denominator, 6 over 2 plus 3 over 2. And that would be 9 over 2. All right, next up here, we'll do a trig equation. So for the first one here, I'm going to factor out a cosine, which leaves me with the sine minus 9 equals 0. So that means that cosine of theta could equal 0, or sine of theta minus 9 equals 0. And then that means that sine of theta equals 9. Now, that actually never happens. Sine of theta cannot equal any number greater than 1, so I'm going to stop on that one. But cosine theta can equal 0, actually, in 2 spots. That could be theta equals pi over 2 or 3 pi over 2. Now, this one is asking for the formula with k. Those are diameter buddies, so I'm just going to write the first one plus pi k. All right, next up here, we're wanting to find all this information on these. I would actually rewrite this list with the common denominator, and that's going to make it a lot easier. So I'm going to call this 10 over 6, and I'm going to call that 13 over 6, and then call that 16 over 6. So I think it's really easy to see there that the common denominator is 3 over 6, or sorry, not the common denominator, the common difference, which is actually just 1/2. So then if I add 3 over 6, again, I get 19 over 6. So that would be the next term. And I'm just kind of following this list here. Now, the formula here, we kind of have to backtrack to find a sub 0, because this is a sub n equals dn plus a sub 0. So I know the common difference is 1/2, but I have to find that a sub 0. So if I subtract 3 over 6 going this way, then that would be 4 over 6, which would actually reduce to 2 over 3. The 100th term then I can just plug in. And so what would that be? Well, I'm going to think of this as 3 over 6 times 100, just to get a common denominator here, plus 2 over 3, which is actually 4 over 6. So I get 300 over 6 plus 4 over 6, So that is 304 over 6, which I would then just reduce down to 152 over 3. All right, next up here, they give us two terms. They give us a sub 14 is 2/3, and a sub 9 is 1/4. So for this, I always find the slope, which is y2 minus y1 over x2 minus x1, and that is really our common difference. So I have 2/3 minus 1/4 for my y values, 14 minus 9 for my x values. So obviously this is 5 down here. Up here I need a common denominator, so I'm going to make it 12, and we'll do 8 over 12 minus 3 over 12. So that is going to give me 5 over 12 over 5, which if I multiply by the reciprocal would just give me 1 over 12 for my common difference. So I know then that's my common difference. I know a sub n equals the common difference times n plus a sub 0. So I'm going to plug in either one of these points. Is one of them going to be easier? Not really. I'll go ahead and use this one. So 1/4 equals 1 over 12 times 9 over 1 plus a sub 0. So this is going to reduce to 3 over 4. So 1 over 4 equals 3 over 4 plus a sub 0 minus 3 over 4. So negative 2 over 4 equals a sub 0. And so that's going to equal negative 1/2. So then my formula then is going to be 1 over 12 n minus 1/2. And then I can go ahead and just plug in 1 to find the first term.